Carpe Diem VPN. Seize the network.
Hey everyone, it's Tim with Carpe Diem VPN here, and today I just want to show off what the current SD-WAN lab that I'm working on looks like. This is my home lab. It's what I'm using just to practice and also to test some of the new features with, and of course to teach other people how this whole thing works. And I just want to go through the basic design of how the lab is right now, and then we're going to expand it. I'm working on expanding the lab. I'm going to add another transport. I'm going to add another branch, and we're going to start adding some more stuff to the lab so that I can start building it and kind of take everyone along on that journey with the extra design for feature templates. And then eventually we can start talking about policy and traffic flows and stuff like that. So let's baseline it. And I've already done a couple videos where I've talked about some of the basic design, specifically about how to get from OSPF to the fabric and from BGP to the fabric. But I really didn't go too deep into the design itself. So I'd like to cover the design real quick, and then what the design will look like when it's finished. And then, like I said, we can talk about what's going to be needed, where the delta is, what's going to be needed to add to the vManage in order to support that new design and support the extra stuff that we're adding. So let's take a look at it right now. In this setup here, DC router 1 and router 2 and the DC core are all together peered through IBGP. So they're IBGP. So excuse my terrible writing with my tablet here. But these are all IBGP peered together. There's no confederation route reflector or anything like that. They're just, each one is peered to the other. And then the SD-WAN routers are in a different BGP AS. So this one and this one, they're not peered together through BGP. This is actually what's called a TLOC extension. This is transport side, so we can talk about that in a little bit. But they are BGP peered to the service side, or the VPN side, if you like. So what's going on here is that this is an eBGP. So here to here, and on this side also, right? So here to here is eBGP because they're in a different AS. Okay, so the eBGP IBGP rules apply here. So it's eBGP peered between the SD-WAN and the server side in the data center. And then within the data center, these three boxes are peered to each other through IBGP. So that's how the data center is set up. It's using BGP. And again, I mentioned here, this is transport side. These are colored for transport. And the TLOC extension is actually just a transport redundancy, where if the carrier gives us a single handoff, so say in this case with Biz Internet, we got a single handoff, we don't have two, rather than having to do something weird like use a switch or NAT or firewalls or anything to set that up, what we can do is we can connect the other router ostensibly to the carrier through this router. And we just have to make sure that that space is advertised or available, that the provider will route that for us. And then this router can actually use that Biz Internet connection to build IPsec tunnels and control tunnels. So this is the point I wanted to make is this is transport side. So these, even though these are two on the same BGP AS, they're not paired together. They are, however, doing OMP. So draw a big cloud around the whole transport. And this is, of course, OMP, the overlay management protocol, which is the routing protocol, if you will, for the fabric. Now, in the fabric, and I covered this in my BGP transport side BGP redistribution video a while ago, we're using a fabric BGP or an overlay AS. So we've got an overlay AS, and what that means is that we're not assigning the I'm trying to remember what the number is now. I don't remember what the number is. I'll have to look it up. I'll look it up in a little bit. I think it's like 65999 or something like that. I'll just say it is this for now, and then I'll correct this when I go look at it. But this is the overlay AS. So the fabric itself has an AS number, and that's for BGP loop prevention, because of course with BGP, the AS path is the loop prevention mechanism. Now at the branches, this branch is running OSPF. Okay, so it's running OSPF, and then so we're peering OSPF with the service side, and this SD-WAN router, of course, is running OMP, towards the transport, the fabric rather. So on this side, I think it is currently OSPF, but I think I will actually, as part of the demonstration process, I will migrate this to EIGRP just to show how that's done, and also to show how EIGRP works, which is it's pretty basic. So that's how it is right now. So this is how it is right now. This is OSPF area 0. And the reason we could do area 0 everywhere, we could do area 0 here too, actually. The reason we can do area 0 in multiple places is because we are redistributing to OMP. And so we're not having to do OSPF area 0 and having any weird things where we're having discontiguous backbones or anything like that. For those who are familiar with MPLS Layer 3 VPN and kind of the OSPF super backbone, this is similar to that, but not really the same thing. It doesn't provide the same purpose or functionality. It's just that we're taking it and putting it into the fabric. So we can run OSPF area 0 in every site where we have OSPF, and there won't be any problems. So this is current. This is our current today, steady state. This is how the fabric is set up. This is how routes are being advertised, and this is just how everything works today. So let's see what we're going to migrate to. So this is what we're going to migrate to. You can see that we're adding an extra color in MPLS, and we're adding a bunch of links to facilitate or allow us to use that extra color. And then we're adding, of course, another branch. We're going to add branch 3. Now in branch 3, we're going to run BGP. And so that's how we're going to do it. And what this will allow us to do, and of course, this is still BGP, and this is still going to be eBGP this way. What this will allow us to do by setting up this third branch and running BGP there is that we can see how BGP and OMP are going to interact to stop, and what kind of traffic engineering we'll need to do to stop loops from forming, and just to see the ability of OMP to kind of carry some of the BGP attributes and preserve some of that best path stuff that we're looking for from a BGP perspective. So we'll take something from BGP. So just to walk through it a little bit, the DC core will advertise a route of some sort, like the maybe the T-Rex emulated server routes will be advertised to DC router 1 and router 2. They'll advertise it to the SD-WAN boxes, and then the SD-WAN boxes will put that in OMP, and they'll advertise it off to, let's see, infrastructure. So vSmart. They'll actually advertise that through OMP over to vSmart. Let's say vSmart's there. Now, vSmart, of course, will, based on our policy, based on our route policy, topology policy, so on and so forth, vSmart is going to then reflect those routes. It works like a route reflector, a BGP route reflector, off to the various branches and other SD-WAN boxes, again, based on our policy. So again, this will give us an opportunity to do some interesting route manipulation and just see kind of end-to-end how we do BGP to OMP back to BGP, how we do it to OSPF, and then EIGRP. And then ultimately, assuming we have it built such that the branches can send traffic to each other, how we go from OSPF to OMP over and then down into EIGRP, and just see how that all is built out. So that's the idea. That's so what are we going to need in order to kind of support that? Like what extra SD-WAN type stuff are we going to need to support that? Well, we're going to need to add some templates around this color. Oops, color. Sorry, scratch that out. So we'll need to add some templates around this color, around this new color that we have as MPLS. So we're going to need to add some interfaces. See, these are new interfaces on these boxes. Of course, this is going to be a whole new, like this whole thing is going to be all new templates, at least for part of it. But see, we've had it here. We've added anywhere we've added MPLS, we have to add interfaces to those device templates for that color, so that we can add IP addressing, so we can tag it with the color, so we can build control plane connections and IPsec data plane connections over it. So that's one thing we'll need to add. That's actually the main thing we'll need to add there. Here, we're going to have to look at our BGP templates for branch 3. You have to look at our BGP templates. And depending on what we plan to do in branch 3, if it's different, we'll need to potentially edit, add, or just change, just extend the BGP templates that we have already. And I say this a lot to customers when we talk about SD-WAN. We shouldn't aim to have like one BGP template, right? We shouldn't try to have one BGP template. I know administratively there's more work in having more templates, and I'm not saying that the plan should be to have a separate template for every single thing that we have. But what we should think about is when a template is applied to it. So let's just say feature template, and just say like here's a BGP feature template, and we're going to attach that feature template to different device templates. So device template 1, device template 2, 3. Let's say there's a different device template for, say, every branch or something like that. I don't know. Let's say that we wanted to have a feature, the BGP template, and we wanted to apply it to multiple device templates. What's going to happen if we need to make changes in one branch, following that branch that we were just talking about, this idea that it was attached to different branch templates? If we need to make any change here, it's going to update, and it's going to have to update and be changed on all of these device templates. Well, what if you only want to make the change in one branch? What if this is the only branch you want to make a BGP change on? Well, if you have to make a change to the template, and the device templates are using this feature template, that change that you push is going to have to go to all of those different branches when you really just wanted to target one. So there's some planning, some administrative, thinking about where we will reuse templates and where we can get away with variables, and where we really just need to make a new template so that we have some freedom to change some stuff without having to affect multiple devices. I generally say that a feature template, depending on what the feature is, should be the same where you can keep it the same, meaning that, maybe just where variables would solve that problem. But again, we need to be cognizant, mostly when you think about a feature template, be cognizant of the device templates we're going to attach them to. If you can think of situations where you're going to want to change something at one of those but not multiple of those, that should probably be its own feature template, or you can keep it the same until it's time to branch out. Then you can create a new feature template, then go to that single device template and add that new feature template, and that way you don't have to update multiple devices. It's like Legos, right? So you got to think, there's just some planning involved there. Without getting too much off on the tangent, these are some of the things we have to think about when we start expanding out our SD-WAN. We have to add support for new color. We have to add support for new feature templates based on what we're doing here, new interface templates. If we were adding a new VPN, which we're not doing yet, I'm going to wait until a little bit longer to add another VPN, but we'd have to create new VPN templates and server-side templates for those VPNs. But right now, this is it. So we should only have to deal with creating new interface templates that reference the MPLS color And then we just need to think about what our BGP design is going to look like here at branch 3. And if it's something we can reuse the eBGP templates that already exists over in the data center. Well, actually, no, we're not going to do that. And again, this goes back to, do we want to have a single feature template being inherited by multiple device templates? I can see many design reasons why your data center BGP might end up being different than BGP you might use at a branch. So we're just going to create new BGP templates for the branch in this case. All right, well, thanks for watching. And as I build new templates and new use cases, and eventually we'll get into policy and stuff, but right now we're still working on templates and expanding out the SD-WAN. As I do each of those things, I'll create a video that kind of walks through that piece. Okay, thanks for watching, and see you next time.